Mr. Reimer has requested, since he missed some school, for me to do an elimination video. So elimination is just another strategy for solving problems like this, right? Problems where we have two different constraints. We need numbers that do this, and they also have to do that. So those are our constraints, right? This and this. And of course, we need numbers that work for both. One method is to do substitution, and I'm going to show you that real quick, just to show that it can work for a problem like this. However, after you learn elimination, even though it's not the best method, you should be able to notice a problem like this would be really easy to solve using elimination. Now, substitution isn't that bad either, and it's for the same reason that elimination is good. So you don't need to know both, but having both allows you to pick your battle and choose how you want to solve. So if I'm doing sub, the whole goal is to get a variable on its own, plug it in, that's the substitution part, and then solve, right? Well, none of these are close to being on their own, right? We have a coefficient of 2, 3, 5, and -3. So, for instance, if I were to get this x on its own, I would have to divide everything in the red equation by 2. So I'm going to have a bunch of junk over 2 and have to plug that in here. And of course, the 2 and the 5 won't divide out, right? Same thing here. If I got this x on its own, I'd divide everything by 5 in the bottom, right? The blue equation. And so I'd have a bunch of junk equaling x, and it would be over 5. So when I plug it in for x here, the 2 and the 5 wouldn't divide out either. But of course, the 3's will. So I'm going to take that red equation, and I'm going to rearrange it. I'll subtract 2x over. Negative 11 was already there. And of course, to get y on its own instead of 3y, I have to divide everything by 3. Now, this is the best move, because when I plug this into the other equation for y, that divides by 3 will go away. And this doesn't always happen when you do substitution, but when it does, it's really nice. So you should try to find numbers that work together nicely to make your work easy. And that's part of being a mathematician. So here, I could distribute the -3, but again, the reason I like this one is because dividing by 3 gets rid of this, right? This becomes a 1, this becomes a -1. And that's why it's important not to just cross things out, right? Think about what's actually going on here. -3 divided by 3 doesn't go away, it becomes -1 over 1. So now when I do this, and I guess I'll do it in purple, I get 5x minus 1 times -11 minus 2x equals 67, right? Because dividing by 1 doesn't do anything. So now when I distribute, I'll get 5x plus 11 plus 2x equals 67. A super common mistake is to subtract these because you're thinking, do the opposite or whatever, but we're not using a property of equality. They're already on the same side. So let's just put them together. We get 7 total x's. And at this point, hopefully you can see the answer, right? What do I add 11 to get 67? Well, 56, right? 56 plus 11 gets you 67. So this needs to be 56, 5, 6, which means that x must be 8. So we found x is 8. So again, we did substitution, right? We got a variable on its own, plugged it into the other equation, and solved. Now that we have one variable, we get the other pretty quickly. So I'm going to plug that in here and here to make sure my answers work. So we know x is 8. We figured that out. So now I've got 16 plus something equals -11. Well, I definitely want that to be negative, so y is going to be a negative. 16 minus 16 would get us 0, right? So 16 minus 16 and minus 11 will get us -11. I want to point that out again. This is 16, so if this part right here equals -16 minus 11, this part right here, right? If it equals -16 minus 11, then I get -11. 16 minus 16 minus 11 is -11. So 3y must equal -27, right? If I'm taking away 16 and taking away 11, I'm really taking away 27, so y must be -9. Now, that should work for both, so let's check that. Now that I know this is -9. 40 plus 27 is 67, so that totally works. So we're going to do the same problem, but we're going to use elimination. And the reason we're going to use elimination is because these coefficients match. So substitution is trying to get rid of one of the variables, and the way it does it is by substituting out one variable for the other. What elimination does is it literally gets rid of the other variable. It eliminates it. And this will make our problem easier to solve. So here's what I'm going to do. I'm going to take this red equation here, and I'm going to add some stuff to it. So here's 2x plus 3y equals negative 11. Now, hopefully you know that I can add anything I want to both sides, right? A property of equality is if I add something to one side and I add it to the other, as long as it's equal, we're good to go. So I want to talk about that real quick. Here's an equation. 2 plus 3 equals 5. That's true. If I add 2 to both sides, it's still equal, right? Totally equal. And even if I add 3 to this side, but minus 1 later, it's still equal because 3 minus 1 is still 2. So as long as I balance it out, it's totally fine, right? Even if they don't look exactly alike, as long as they really are alike, right, the same number, then we'll be good to go. So here's what I'm going to do. I'm going to add some weird stuff to this red equation, okay? So I'm going to add 5x to this side and minus 3y from this side. And you might not know why I picked those numbers yet. I'm going to show you that in a second. It's not because this is 3y and I'm minusing 3y. No. That's a coincidence. So just hang tight. So I did this, right? And if I add 5x and minus 3y from this side, that's balanced. It's weird, but it's balanced, right? Well, I'm not going to do that. I'm actually just going to I'm going to add 67 to this side. And you might think, wait a minute. I did this to the left side and did something completely different to the right side. This isn't balanced. And I would agree, under normal circumstances, this would not be balanced. 5x and minus 3y isn't the same thing as adding 67, right? However, if you look at the original problem, they told us that 5x minus 3y is 67. So what we did to this side, we did do to the other side. I added 67, that way I can actually combine these terms. And instead of adding 67 to this side, I added 5x and negative 3y because I can combine those terms. So it is balanced, and I'll actually be able to combine these terms to something nice. And what's really nice, as noted earlier, this will become 0. That variable will get eliminated. So we get 7 total x's, 0 y values, right? So one way to write that would be plus 0y. And of course, 0 times anything is 0. And adding 0 doesn't do anything. The key thing is, don't write a single y down here, because of course, a single y is equal to 1y, right? Not 0y. So whenever this becomes 0, don't write 0 y's and think it's 1y, or just write a y. It's nothing. It's gone, right? That's why we did it. So it's 0 now. Cool. So we're not adding anything to that 7x. It's gone. And then over here, we have negative 11 plus 67. I'm going to think of it as 67 minus 11, which gets us 56, which might look familiar from that earlier problem, right? That's exactly what we got when we did this. But it took us a lot longer to get there, right? So because that these right here were the same thing, right? 3y and 3y, we were able to eliminate them by adding the two equations together, right? Adding the left side of this to this equation and adding the right side of this to that equation. And it got us our answer really quick. X is 8. And after we get x is 8, we plug it in and get the other one. So I'm going to zoom out real quick. So I noticed that these two have the same coefficient, 3 and 3. And I noticed that one's positive and one's negative. So basically, I reason that if I add the left side, this stuff here, and I add the right side to these equations, I can end up getting rid of one of the variables. We call that elimination. Now, as you might expect, most equations don't line up this nicely, right? So you might end up doing a lot of work to make this work when you could have just done substitution. Now, this was pretty quick, right? I didn't go and find the other variable yet. We did that on the other page, but you'd plug it in and get your answer, right? X is negative, or Y is negative 9, I should say. Right? When you plug in that 8, you get 16 minus 27 is negative 11. However, I want to show you another problem. And this problem isn't a prime candidate for elimination, because you'll notice the coefficients don't match up, right? We have 2 and 4, 7 and 3. However, the coefficients are close enough where we could still do elimination, and it might save us a little bit of time, right? If I did sub, I'd have to divide everything by 4, plug that in, things would sort of go away, right? That wouldn't be too bad. But I'm going to show another example of elimination here. So right now, if I add these two equations together, if I take this side and add it here, and then, of course, to keep it balanced, I'd have to add negative 5 to this side, or both of those, right? I'd rather add negative 5. Nothing's going to go away. I'm going to get 6 x's, I'm going to get negative 4 y's, and I'm going to get 7, right? So nothing would get eliminated. However, if you really want to use elimination, one of the things you can do is you can take this bottom equation, and you can notice that if I were to times the bottom equation by 2, right, every single term, of course, what we get is a new equation, a new bottom equation. So our top equation is still 4x minus 7y equals 13. And that bottom equation, while the numbers are bigger, it'll still be the same equation. It'll still have the same properties. But now, you'll notice that the coefficients are the same here. Well, last time we added because they were opposite signs, right? That's what made it 0. I want to get rid of one of these variables, so I want one of the variables to get eliminated. Well, here if I add them, I'm going to get 8x's, right? It's not going to go away. So instead, I'm going to subtract them. And subtraction's kind of dangerous here because a lot of people forget what they're doing halfway through the problem. Most people realize 4x minus 4x is 0x's. It goes away. That's why we did it. But then they forget here what's happening. They think negative 7y plus 6y is negative 1y. And that's true, but we're not adding 6y's to this. We're actually minusing 6y's. So we end up with negative 13y's. Again, here people tell me it's 3, and that's true if you were doing 13 minus 10, but we're actually doing 13 minus a negative 10, right? We subtracted 4x to make 0. So we had to subtract 6y, and we have to subtract negative 10, so we actually get 23. And our answer is going to be a fraction. This can happen sometimes, no big deal. You can write it like this with the minus on the bottom, you can write it like this with the minus on the top, or you can write it like this with the minus on the side. It really doesn't matter. Negative 23 over 13 is the same thing as 23 over negative 13. So I'll probably write it like this, but you do you. So that's our y value, and now that we found our y value, we can plug that back in and get our x value. So this was still pretty quick to get our x, or our first value, right, for y. But we're still going to have the same problem substitution has, where we plug this in and the numbers are kind of nasty. So I think I'll plug this into the bottom equation, this one right here. 2x plus 3 times whatever y is equals negative 5. And we said that y was this. I'm still going to have to times everything by 13 to get rid of that fraction. And a common mistake a lot of people make is they times by 13 here to divide this out, which is beautiful, right? They both become 1 over 1, and timesing by 1, dividing by 1 does nothing, so it kind of goes away. But then they also times this 3 by 13. This is all one term, right? It's something times something, so we don't need to times that 3 again. So what we get is 26x's. And then if we distribute that 3, we get negative 69, nice, times 1, divided by 1. So still just negative 69. And then this becomes negative 50, and 15 is 65. If I rearrange this equation, I can add 69 to both sides. And it'll make it easier to see the answer. So this becomes 0, that's why I did it. And this becomes 4. So x is whatever I times 26 by to get 4, which of course is 4 over 26. I can simplify that to 2 over 13. Cool. So x is 2/13, and y is negative 23 over 13. So elimination doesn't save you from getting nasty answers. Sometimes that's just where the two equations intersect, right? But it can save you a little bit of work. You might notice that the amount of work that's here looks pretty similar to the amount of work we could have done for sub, which is why I wouldn't say this is a prime candidate for elimination. But if you find an equation where the variables match really nicely, like this one, right? Going ahead and just taking those and adding them together will be a lot faster than doing all this other stuff. So it's good to have elimination in your tool belt. That said, when we get to nonlinear equations, right, multiple variables on a term, or maybe we have like squareds or cubes, then elimination won't be nearly as useful. In fact, most of the time it won't even work. So really master substitution. While it is a bit, lengthy, you have to write down some stuff, the process isn't that hard, and it's going to be really good for you to learn algebra. So that's the idea of elimination, right? Adding or subtracting two equations together, basically, in order to eliminate a variable. Sometimes they eliminate nicely. Adding these together got rid of our y instantly. Sometimes they don't, and you have to multiply to make things kind of match up, right? When you have to do this, especially if you have to do it to both equations, right? If I wanted to make these two match, I'd have to times them all by 7 and all by 3. by the time you do that, the amount of work you've done is probably a little bit more than what substitution would have been. So proceed wisely, use these tools correctly, and try not to force, don't use a hammer on a screw, right? Make sure you use the right tool for the right job. All right, cool. That's it for elimination.